Our next presenter will be Deshaun Dewberry. Roberta, if you could stop sharing screen. Deshaun?
Question.
Yes.
Dr. Sosanya, do we have to do the complete the form for each individual, or we do as a group?
Yes, each individual.
Okay.
Yes.
All
Okay.
right. Thank you.
Normally we have students working in groups, but because of the pandemic, because of COVID, that's not encouraged. So students had to work individually. Yeah. Okay. So individual project evaluation or presentation evaluation. Dewberry, Deshaun Dewberry is our next presenter on digital thermometer, touchless thermometer. Dewberry, are you here?
Yes, I'm here.
Okay, so you can share your screen. Ready?
Do y'all see the screen?
Not yet. Okay, just make it view screen. Share your view full screen.
Sorry.
Full.
Hello,
Yeah.
everybody. My name is Deshaun Dewberry, and I will be presenting the digital infrared thermometer, or DIRT. The purpose of this project is to design a no-contact thermometer that can detect and measure temperature using infrared sensors. Digital infrared thermometers are normally used in medical settings / hospitals or clinics, but due to the pandemic, places of business have shown an increase in need and usage of these devices. What is a digital infrared thermometer? A digital infrared thermometer is a distance-driven device that is capable of measuring infrared by detecting the infrared radiations that bodies emit. There is a common misconception that digital infrared thermometers expose people or patients to radiation or infrared rays, when it's actually the other way around, whereas the infrared sensor, is picking up the infrared radiations that our bodies emit. Here are some examples of digital infrared thermometers. One is from Walmart, the other one is from Amazon. This is the setup and like the picture of how the digital infrared thermometer will look. I mean, it still needs like a chassis and everything, so I will be still working on that. There were two ways of implementing this project. One was Arduino and the other one was Embed. Both are operating systems and both use C/C++ language, although Arduino is simpler to understand and work with. The materials that I use are the Arduino board, which is used to give the power and to control electronics such as the digital infrared sensor or LCD display. The Grove digital infrared thermometer sensor is an infrared sensor to detect temperature. A I never know how to say that. Potentiometer knob that counts as a variable resistance, which is read as an analog value. And liquid crystal display, or LCD, is used to output characters such as letters, numbers, or statements. Here is the code that I used for the digital infrared temperature sensor. Here's how everything works. So the Arduino board supplies a 3.3 voltage / 5V voltage to the digital infrared temperature sensor. The digital infrared temperature sensor is grounded and also connected by SCL, which is a clock line, and SDA, which is the data line pins. In this case, I declare the SDA pin or the data line pin to A3, analog pin 3, and SCL pin to A2 or analog pin 2. The same 3.3 voltage, 3.3 volts / 5 volts is given to the crystal display in order to give it power. Complete code is then run through the Arduino IDE first and then sent to the Arduino board in order for the other components to display the desired output. So this is the setup or digital infrared thermometer setup. Right here, you got the digital infrared temperature sensor, the Arduino board, the Arduino breadboard, and the LCD display. This is the whole setup right here. Right now, it's running the code to get the temperature, which I will be showing soon.
We can't hear you at all. We've lost audio with you. Deshaun?
No, I'm still here. That video didn't have no sound. I know it didn't have no sound. I'm sorry. Give me a minute. Okay, before I move on, I want to give a quick couple notes on the last video. I know it didn't have no sound. That was done on purpose. It was just to show the code and the output. What I discovered was that the temperature sensor actually was outputting the Celsius and 30 degrees. Well, some of it was like 26, 27, 28, 30, 31, and so on. And that was in Celsius. And of course, you got to translate that to Fahrenheit, which 30 degrees Celsius is like the normal kind of thing, is either around 80 or 90, which is almost kind of normal-ish for temperature. Okay. So here is some future work / additional work. I also noticed that I also know that I didn't show the LCD, and it's because I plan on fixing it so that it can display the output. Other things that I want to do today is build a chassis for the digital infrared thermometer so it can be more stationary, more mobile, so that you don't have to be at a computer to use it. Also, I want to implement a power source, whether that be a battery or whether that be some way to charge it. Any questions?
Yes, you did not display any electronics at all. Your circuitry to show us your understanding of the electronics design that you did. I didn't see your circuit.
Is that in the video?
I did not see that in his presentation. He needs to display the circuitry, the electronics circuit design aspect.
So you want like a diagram of it? Or
Oh yeah, your circuit schematics. Yeah.
Okay.
That is supposed to be in your PowerPoint presentation. Are you talking through the circuits? Explaining the circuits.
The demonstration.
Is there any other questions?
You do not have the electronic circuits?
What do you mean?
Yeah, you've done presentation on this before. We started with your electronic circuit, telling us how you wire up your circuits, what components you wired up, and how you do your conversion and all that.
I thought I went over. I thought I went over that, but I probably didn't.
We didn't see any electronic circuits, schematics.
Oh, I described it. That's okay. Okay, I understand what you're saying. I described it, but I didn't show the schematic.
That is important.
Platform, which enables
I'll update this PowerPoint.
Computers remotely by internet.
Okay.
Just like what Geek Squad from Best Buy.
Is there any more?
Hands, please. Can you mute yourself?
Sorry. I was almost going to ask you a question as well. I like this infrared related technology as well.
Thank you.
I like this infrared electromagnetic spectrum and theory.
Any more questions for the presenter? You almost likely have to repeat this presentation for me to record. We did progress report in the class where you have presented a couple of times. Yes?
Yes.
Okay. The electronics, your understanding of the electronics aspect of the project is crucial at this point. You did that in class, but you just left it out of your presentation today completely. The audience would like to know how you work out the circuitry to do the conversion. Okay?
Okay.